This video will be addressing how to handle the problem 326 on page 326, number 31, A, B, and C. Before we get going on that though, I want to do a quick review of this little guy that tells you how to get from one unit of measure to another. And the way it's set up right now is grams would be the given and particles would be the find. Now, what you have to do is look at what is between the arrows. So, if I move the arrow over here for find to the mole section, you're only going to have one thing between you and your answer, or between the given and the find, I should say, and that is right here, the molar mass. So the molar mass, along with the given, makes a total of 2 fractions. Likewise, if the find was here and the given was here, you would be having only, whoops, given was here, there we go. We'd only have one thing in between it, in between the arrows as well. And that thing would be Avo, which is the 6.02 times 10 to the 23rd equals 1 mole. When we got into problems recently where we had given on the far end and particles on the other end, as you see here and here, what that means is we're going to have 2 things in the middle. We'll have the given over 1 as the first fraction, then we'll use the molar mass to get to moles, then we're going to use the Avo number to get to particles. And that would be the same if we had reversed this and we started with particles. We would start, the second fraction would be Avo, the third fraction would be the chart, and particles over 1 would be our beginning. And I wanted you to see what happens when we go and reverse our directions that we're starting from and ending. If we start with particles, what the fraction is going to look like this. We'd have particles over 1, the Avo number, and grams. And particles has to be down here because particles is up here. And moles is up here, so moles has to be down here. When we go the opposite direction, what happens is we are starting with grams, and so grams is over 1, and grams is on top, moles on top, grams on bottom, because grams is on the top here. And then moles on top and moles on the bottom to get to our last fraction, which is using the particles, and that's how we solve it in reverse. So, reverse is just reversing the arrows. Alright? So we're just reversing the arrows. That's what I mean by reverse. Now let's look what happens when we go into reverse. Reverse means that, look, grams is over moles here, but in this fraction, moles is on the top and grams is on the bottom. It got flipped on us. Likewise, this guy has moles on the top and particles on the bottom, the Avo number, and down here, the particles is on the top and moles is on the bottom. So it's just something for you to keep in mind to help you get the overall big picture. Now let's go and look at the problem. In this problem, we've got silver chromate. And silver, you'll notice, is going to have 2 silvers and 1 chromate ion. And notice the chromate ion is all one piece. It has 4 oxygens on it. And I tried to do this to look like 3D. So these guys here would be back behind, and these guys here would be up front. But at any rate, this is all one piece, and watch what happens. Aha! It all moves together. Now when we go to the next one, oops, we're going to go down below here. And in class I was able to do a nice little demo to show what a precipitate is like, which is what we have up here, and how it is different than when we put that stuff into water and we have a solution. So in a solution, all these guys break up and they move independently in the water. See, the silver moves here. And when we were up here, we had the solid. So there's a difference, and they're asking you in the question the difference between how many silvers we have and how many dichromates, silver dichromate we have. So we're going to look at that and see how to make it work. You're first of all going to have to do the kinds of problems that we've been doing, which is 3 fractions. And we're going to convert the given, which in this case was 25 grams of silver chromate. And we're going to move that into particles. So this is very similar to what we've already done in our homework, so I'm not going to spend a lot of time on it. Our first fraction is the given over 1. So 25 grams of silver dichromate. So there we are there. And our next fraction, we're trying to go to particles, but we have to have a second fraction before we do the particles fraction with Ag1. So our first guy is going to be molar mass. And the molar mass, the grams has to be on the bottom, and the grams here is on the top, so that will allow the grams of silver dichromate to cancel. And so what we can do is circle these guys right here and here, and we can cancel them out. And I should have included the silver here. There we go. And now we go to our next fraction, which is going to be the Ag1 number. And because moles of silver chromate is on the top here, moles of silver chromate has to be on the bottom here. And there's something I want to warn you about, and you need to watch for when you're doing equalities into fractions. 1 mole of anything is equal to 6.02 times 10 to the 23rd. And in this case, we had silver dichromate, Ag2CrO4. And this is also Ag2CrO4, only this time on the right side there, we have silver dichromate pieces, and this is moles of silver dichromate pieces. So that's the difference in those two. Now what we want to do is look at the units of measure. The units of measure here and the units of measure over here, where we have just pieces. So the number, which is 6.02 times 10 to the 23rd, this guy here, stays with this guy. Moles of silver dichromate, the 1 stays with the moles because it's next to it. So whenever you have a unit of measure and you have an equality, look to the number to the left of the unit of measure, so that when you do this part down here, it's supposed to be moles of silver dichromate. We're going to have moles of silver dichromate, but we also know that this number 1 is going to be right there. And we also know that the other guy, which is going to be particles of silver dichromate, or silver chromate, not dichromate. I'm sorry, I've been saying it wrong through the whole video. So let's get that corrected. This is silver chromate. But this guy right here is going to be the number that goes with it. And so when we look at the answer, when we multiply and divide everything, we come up with 0.468 times 10 to the 23rd. When we change that to scientific notation, we have to move this guy to the right, and this guy right here, the 10 to the 23rd, is also trying to move things to the right. So whenever we move something to the right, like we did here, just a second, let's get the pointer, there we go. Like we moved here to the right, and this is trying to move to the right. So when this guy comes over here, the decimal, then this guy doesn't have to go as far to get to the same place that it would have gotten to with this number. Okay, so there's the number right there, and that is going to be less. So here's our final answer for this one, and we are going to use this now as the basis for answering the first 2 parts of the question. So you have to do all of this just to get started on the question, which seems really weird, but that's the way it is. So let's go on down and let's talk about converting. And we'll leave that answer up there. And we're going to convert particles of silver dichromate to, or silver chromate, not dichromate. I've been saying dichromate because I showed some some potassium dichromate to the students to see the color of the chromate ion and the dichromate ion. So we're going to change these guys to particles, but we've got to get a ratio to do that. So we're trying to figure out what the ratio is. Well, that number is going to be determined right in here. See this 2? Every one of these silver chromates, and let's go back and look at the whole piece. Silver chromate, when you look at this guy, you're going to be having 2 silvers for each one of these silver chromates. They move as a piece because they are a piece. And so what that means is we have a ratio. The ratio of the ions or the ion of silver to the silver chromate. That ratio is going to be a 1 to 2. Okay, you see 2 silvers for each silver chromate. Oh, I got to stop saying that. So we use that ratio to find our answer, and that's going to happen right down here. So let's look at how this works. We're going to have, because of our answer up here, or because of the answer up here, we can take that number and start our calculation down here. So this is what we're starting with. This is the whole molecule. And now we're going to use the ratio of silver to silver dichromate, or the silver chromate, not dichromate. I'm going to stop saying that sooner or later. Ag2CrO4 is going to be on the bottom. There's one of those. And there's going to be 2 silver ions. Now, because there's 2 silver ions, that means that all we have to do is essentially double our answer that we got up here. So when we double that out, we come up with this answer. So that would be our final answer for letter A. And now we can go on to letter B. And in letter B, we have the same kind of deal. We're going to convert particles of silver dichromate, or silver chromate. Wow, I'm really stuck on dichromate, aren't I? Let's get this down here. Okay, convert the particles of silver chromate to chromate particles. Well, we look at how many chromates we have in here, and that's only 1. And so the number of chromates to silver chromates is a 1-to-1 ratio. And that's going to make this whole thing very, very easy. So here's our ratio of these 2 guys is right here, 1-to-1. So we're going to use this ratio to convert this stuff into this stuff. And when we do that, the numbers are going to look like this. We're going to take the same starting point, which is 4.68 times 10 to the 22. And let's speed this up a little bit. I'll put in the numbers and then I'll show you what we have. So there's our final answer for this guy. It's essentially what we started out with because the particles were a 1-to-1 ratio. So well, our last one is the one that doesn't seem terribly intuitive. You calculated the number of Ag2CrO4 silver chromate molecules that are represented by 25.8 grams of silver chromate in the first step above. Now, we're not going to actually convert that. We're going to leave that alone. I should get rid of this. What we're actually going to do is we're going to take the molar mass of the silver chromate here, and we're going to convert that to, we're actually not going to convert it. We're going to divide it by the Avogadro number. So this is the grams that equals 1 mole. This is, for 1 mole, going to be this many particles. So what they're asking for is the grams per particle, and we are talking about Ag2CrO4. And this is also Ag2CrO4, and this is Ag2CrO4, and this is Ag2CrO4, all the same particle. And so what we have at the end is the 322 divided by the AVO number. And let's see what that comes out to. Okay, so your final answer here is going to be right down here. Let's get this guy pointed over. And so you've got 5.51 times 10 to the minus 22 grams per molecule of silver chromate. And the way we did that was dividing this number by this number, because we moved this decimal to the left, which is the same direction that a negative exponent would move it. That makes this negative exponent smaller, and there we go. So our final answer is right down here, and we've got everything settled for our final answer. So keep in mind, when you're working with these powers of 10, when this guy goes the same way as this one, it's going to reduce. If it goes opposite, then it will be a larger number. And our final answer being down there, and this is by taking the molar mass, which we figured out earlier on, and we divided it by the AVO number essentially. And that's what this calculation was all about. Hope this helps you for future problems.